Hello, it's Andy with Mountain Computers, the Go Green PC Tune-Up Guy. Today is Monday, I think it's August 26th. Anyhow, what I want to cover right now is... what happened? Oh, here we go. Oh, it's cold outside. I was just working outside. Came back inside. This is my daughter. My youngest daughter, Vanessa. She drew this for her mom and said, "Oh, Vanessa, the prettiest star in the world." So we got a picture of that. So we're done. Okay. Had to prove that it existed. So she'll be in the videos. Today we're extending our anomaly detection on some of our hardware and software solutions, both on the LAN, on the WAN, and in the cloud. So let me describe this for you. So we have this thing called anomalies. Anomalies. Just anomaly detection, okay? I know my other AWS video, it was pretty well received. It was a little tough, but we finished that, posted it, then took it down, ran it through some review, let some people look at it first and said, is that a little too rough and terse? Based on some of our interactions with some clients and some folks. And they said, it's okay. You're not out of line, you're doing okay. The thing is, right, the reason why your stuff doesn't break and people are modifying that are outside our control is because our infrastructure is really strong and we have layered security all the way through. And the funny thing is about that ISO stack that I forgot, I had application presentation backwards, and of course transport was in there. So anomaly detection, let's talk about this. Now it doesn't matter what cloud platform you're on, it's all the same. Now remember I told you about the freeway, right? Here's your freeway. Your customers are in here, going up, doing stuff. One of the things I learned in manufacturing, IT manufacturing, supply chain, you name it, anything, is that you have upper control limits and lower control limits. And then if you get outside of one of those, that's called an anomaly, or go below it, that's called an anomaly. Basically what that says is that whatever this is, if it's a CPU, hard drive space, network, any of your natural resources that are limited, even though you might have scaling and other types of ways to expand those resources, control them, limit them, move them around, make them more flexible. The one thing that you have to understand is that for the longest time we've been doing some of that detection manually using tools to scan things and say, okay, usually you'll see a blip maybe once a month, maybe once every 2 months. However, some of these foreign entities from Russia, Germany, China are getting pretty tricky. Now, this anomaly, there's two. I'm going to tell you two that work. One that's sort of old school that we're going to go back into a tool we call IAM. It stands for Is It Me? That means, is your system, is your infrastructure having a problem, or is it somewhere else? Is it somebody else? Is it me or not? So the Is It Me is more at a hardware level. And let me explain. I'm just going to say this. It's pretty simple. But fair wear and tear of hardware is tough to detect in the cloud. Okay? So that's why they have all this redundancy and they have all this special engineering behind it. However, you can sense it and be prepared to where even if you have redundancy between zones, between regions, etc., in your VPCs or whatever, you can detect it. And I'm just going to say it's the temperature. Okay? Hardware. This is a big one. On your PC, on your servers, on your network, in your data center, in the cloud. Temperature, there's a range, a manufacturer range for all things. There's tools called like HW Info and SPECI or SPECI, whatever they call it, SPECI. Those are used just to do spot checks. But what if you built that into your model? It's where it's going up and down, and then it goes woo, it goes woo, woo, woo. regardless of who's in charge, who's monitoring. Those are anomalies that should be detected, and if the temperatures are like this, and you're going down the week, down the month, and you start to see those temperatures naturally rise, they can be good. You may change your control limits to go a little bit higher, but you should start to see this pattern, okay? Now, we see the patterns manually because we spot check our systems, we spot things. Now, if everything's clean and running normal and nobody's doing anything stupid, it should be fine. However, we're going to automate this, okay? We're going to add this into our IAM tool. We're going to add this into our Go Green PC tune-up tool. And temperature sensor alerts, okay? Even in the cloud, you need to be cognizant of temperature. For a long time, I didn't really worry about it. I mean, 3-4 years. But for PCs and LANs and WANs, I monitor that. Now, there's no other tools that I know of, like SolarWinds or all these other technologies that sort of go out and capture your applications, your DHCP, the things that are connected in your network. But one of them that I've never seen is temperature collection. Now, just because I haven't seen it doesn't mean it doesn't exist. However, I want you to know that's one of them, is temperature. What was the other one? I forgot about it. Temperature. That was a big one. Temperature. No, I think that's it. Maybe just anomaly detection. Well, we'll just do temperature for now. Now, we're going to expand our tool set to report that in and alert and monitor us for fair wear and tear and breakdown of hard drives, systems that are dirty, systems that are overheating because of high utilization, anything that's outside the norm. Now, we're not going to create a ton of triggers, okay? Because I know for a fact that most of these temperatures are always within specs. Otherwise, they basically auto shut off. That's what thermal protection's for. So again, this is Andy with Mountain Computers, the Go Green PC tune-up guy. This is just one thing that I was going to tell you about anomaly detection. We're going to do temperature, okay? Doesn't matter what it is, C, Celsius, F for Fahrenheit. But yeah, we are going to start capturing temperatures. Systems up, systems down, systems off, systems spiking or staying up here and then coming down. All of these have patterns. So that'll be something interesting. I think we have done some benchmarking and testing for various, performance utilization over the last 15 years. And in the first couple of years, I did a lot of benchmarking using folding at home, cloud computing. And that's just distributed computing from the SDSC, SD San Diego Supercomputer for protein folding and all that stuff. They use that for COVID too. But I've been using it for a long time just to benchmark, two systems side by side, running a job, similar jobs, one with a Go Green PC tune-up, manually applied, and then one not applied, and see which ones, based on period of time, which one gets the job done faster. And Go Green PC tune-up always saves 20, 30, sometimes 5%, sometimes 50% in processing power, just because, all of the bells and whistles are turned off and everything's streamlined and dialed in. Not to break IEEE standards, but like I said, this temperature thing, I've been thinking about it for a little while, a couple months, and actually a couple of years, but you don't get around to it. You love my hat. I mean, it's cold outside. It was snowing this weekend, but here in Reno, and hailing and all that stuff. And I was walking every morning and night, and I was getting really cold, so I got stuffy nose. So other than that, though, be sure to like, subscribe, and share, and we'll be back after this. Thanks. Bye-bye. Hey, this is Andy with Mountain Computers. Again, that anomaly detection part, that video I was just telling you about, I'm the Go Green PC tune-up guy. The first one was temperature, okay? The second one, and I looked at my hat in that video because I just looked at this video, and my hat was all messed up. It looked like, some goober. but it's okay. At least I'm warm. The second one, this is the first one, anomaly detection. The second one, for lack of better, I'm just going to say it's JSON, okay? REST, API, string. It's this stuff. This one here, this is new. We're going to add this detection, and without breaking any terms or conditions or anything like that. And we'll test it in some of our developer accounts on different clouds. We have Google Platform Cloud, we got Azure, and we've got AWS. We don't have an IBM. But this one here, our logs for some of our legacy apps, they started growing. I mean, from megabytes per day to 3, 4 times, 5 times that. So we were like, oh, no problem. It's just, heavy usage, just more usage. Nothing was breaking, nothing. Our databases were secure, all that stuff. SQL injection was being taken care of. However, when I told you about these other 3 entities, other parts of the country, and we have ACLs, and we have all sorts of stuff that's limited to them, we're not using some of the native cloud features because, 1, we don't control them. Number 2, we don't know how they're really working in the back end. We don't know how they're actually taking our good and bad traffic data and using it. Now, the important thing is for us to I've written my own load balancers, my old application balancers, my own database balancers. I've written them all. Sometimes you put them in the database, sometimes you put them in memory. It just depends. Just depends on your application, and you can try both. However, these logs started getting crazy. Now, it was probably January or February, and so we went back and we saw what they were doing. They were doing some crazy stuff. It wasn't breaking anything. They couldn't get anything anyhow. Our databases are designed not to store private information. Okay, an email address isn't necessarily private. Date of birth, all these other things like a PIN number, or because people use the same passwords. They use the same. Even when you hash them, put them into some SHA-256 hash. Even MD5 can be hacked. Don't put anything in the clear. Obfuscate your data that's in a database. However, don't put anything in there that they can use other than an email address. So what? You can't hack it. That's our only key value that we keep in the clear. Everything else is, just linked references. But then our anomaly detection for this is at all those layers. At the application layer, at the presentation, session, all these layers. All the way, we have protections that go all the way down this stack. And not only for some of our applications that we've grouped, but for some of the applications that are isolated. Okay, so one of the applications that I was looking at, and we were getting these orders, and repeat orders. And I was like, that doesn't make sense. The person placed the order. And this is an application that's been running for 20 years, okay? Pretty solid, pretty robust, and it's got over 1 million users plus, and the thing is, right, when I looked at that data, I looked at those logs, I was like, oh, these guys are being tricky. So then I looked at their IP address, and then I routed them all back to all their homes, and they not like they can spoof that stuff. We actually have detection that sees patterns, and we link people to stuff. But they're trying to get into my client's data. I put it in there. I designed it to where we have rules, pattern rules, and if you break them, we just throw back data message error. We don't tell them. I mean, some of them, they try and break our denial of service or SQL injection or something like that. But that anomaly detection, for the past 48 hours, I talked to a couple of the owners, and this is in some of our classic applications, some of our legacy applications. I just told them I'm going to beef things up a little bit. And I looked at some of these hack attempts inside these strings, and they're pretty tricky. And so I went to duplicate some of their attempts to hack into our systems, and they couldn't get in. And even if they did, they can't steal anything, okay? Because everything's obfuscated. I mean, we don't store anything. We put all of our liability for transaction processing on our third parties, okay? We hand them everything. We hand them the client. We don't process anything internally to limit our liability. Because if we did store things, if we did keep things, then we'd be liable. I mean, like one client, I can't remember, there's PII, there's Safe Harbor, there's GDPR, whatever. That's Europe. That used to be called Safe Harbor in a way. And we have PII, blah, blah, blah. We got HIPAA, okay? HIPAA. All these things. You don't store any of this data. You don't store any of this data. And if you do, if you're a medical client, like some of my clients are medical, make sure it's not on your side of the fence. Make sure it's on the other side of the fence. And then at the same time, make sure you obfuscate things. Everything's secured. Everything's SSL. All your endpoints are accounted for. And that's it. So I wanted to extend this. Our anomaly detection has been improved in this area. I can't tell you what the secrets are. I can just tell you. I looked at 3 different countries going hard at it. They couldn't get in, but they kept on ringing the doorbell and hitting the door, trying to kick the door in on some of our systems. And, quite honestly, I mean, we can handle 50,000 simultaneous sessions per second on a really light application. And then we have redundancy behind that. And then we have redundancy behind that. And then we have layered security right on down. Now, I don't want to say this just to be, but we designed this 20 years ago, and it's just been rock solid. However, the players have become more. And it used to be just one player, came out of China by Australia. Now it's all over the place. And all I can tell you is, when you do anomaly detection on your temperature for hardware, not more additional anomaly detection in your application, and I'll just say your LAMP stack or your Microsoft stack or whatever stack you've got. Now, I did mention you have the LAMP, you have the Microsoft stack, okay? You have the Microsoft stack, Microsoft, and you have the LAMP stack. That's Linux, Apache, MariaDB. What's P? Python? No, PHP. Actually, I want to say Python, but it's really PHP. Microsoft, you basically have the server, Windows Server, IIS, MS SQL. What's the last thing? Oh, programming language. Well, they could use VB.NET now. Okay, I use ASP, X, and Classic, and then I use OLADB. Okay, I use OLADB on all my connections. It's a native connection string. It's the fastest. A lot of my Microsoft folks used to do Microsoft SQL to all sorts of different database connectors, but they never use OLADB. And I said, why? Oh, just run it through the registry. No, you can't. You take a 20, 30, 40, 300% performance hit when you go through the server. Okay? Go directly from the app to the database, and you'll get 1 million records back in 8 seconds. And even if you do your cursors or whatever have you, it's fast. Just use OLADB. And when people try to hack that, keep your strings parameterized so they can't really figure it out. Now, what I did here was I enhanced the string side. I enhanced the rest side. But the Linux side, the AWS Game Day people, one of the guys, I think his name was Scott, he was the old school PHP, and then the other guy, which I think his name was David or something like that, he didn't like PHP. He just loved to throw egg on this guy's face for PHP. And I was like, no, it's okay. I mean, I know a bunch of Google engineers who design websites still using PHP. Okay. However, there's this other Java, Oracle bunch. Okay. So you have this one, normal, normal. I'll say normal. But this group here, I don't want to diss on these guys, but not too expensive to maintain. Not too expensive to maintain, but a little bit more expensive, depends on the engineers. But this here, very expensive to maintain. And your security models for this are totally wide open and loose. I mean, seriously. I mean, this Java stuff, this Oracle stuff, I have seen such nightmares in developers who don't program security into their applications from the word go. So anyhow, that's Anomaly Detection 101 for a Monday. And I just want to tell you, whatever you do, have projects that enhance and expand your feature sets. And don't go crazy, but be sensitive to all the other risks and rewards and legal issues that you got to deal with. Back up your stuff, back up your code, do good debugging before you release the stuff, and if you do release it into a test environment, debug it real fast, run your test scripts, run your test suites, look at your log files, and that's it. So again, this is Andy from Mountain Computers, the Go Green PC Tune-Up Guy. Be sure to like, subscribe, and share. Smash that subscribe button, and I appreciate it. So have a great end of April. It's cold outside. It's like froze last night. I had a whole bunch of stuff outside that got frozen, and that's bad. So anyhow, talk to you soon. Bye-bye.